Hello, my name is Will Paris, and this is my Physics 2212 Lab 2 Charged Tape Revisited. In this lab, it is an extension of the experiment we did in the last lab, where we collected data on a piece of floating tape over another piece of tape. So in this lab, we used charged tape to explore and compare line and point charges. In this portion of the experiment, we break the tape into segments in order to more accurately determine the electric charge on the tape. In this lab, we use Newton's second law, F equals ma, as well as Coulomb's law, F equals kqq over r squared, in order to calculate the charge on the piece of tape. We then can use our equations for a line charge to find a more accurate charge for the tape. The two pieces of tape are my systems, and my surrounding is the room around it. In this experiment, two pieces of tape were placed downward on a table, one on top of the other. The tape was ripped quickly and hung near several objects in order to determine the charge. The removed tape was hung above the original bottom tape and began to float. The distance between the tape was measured. When determining the charge of the tape, we found that it was positively charged and lost electrons in the transfer, ripping of the tape. I measured the tape to be 0.2 meters long and 0.02 kilograms. We then created a code sequence that analyzed the data found and calculated the total charge Q. This was done by treating the tape as a line charge. So this is the code that I used in CloseScript in order to do this. I took my data from the last time. I defined my electric field. I created with the principle of superposition, and then I used this other function on the right to create the line charge. And then I created my model here on this next page, and then yes. So after plugging my found numbers into the Go script, that lambda used the idea that lambda, the line charge equals Q over L. I found that the magnitude of the electric force is 2.667 e to the negative 3n, and the gravitational force is 1.96 e to the negative 3n. We can see in this experiment that the force calculated for gravity is larger than the force calculated in electric force. After calculating the force, we calculated the Q as 3.1607 e to the negative 7. This was done by setting my gravitational force equal to this was done by using the gravitational force as equal to my electric force. Although this is a very precise calculation, there are many sources of possible error in the experiment. The first is human error in calculation of distance and mass. Another is that this assumes that each tape is the same Q. Also, some charge of the tape could have dissipated as people touched it and the charge is detected. This data is also not perfectly accurate as we broke the tape into a finite number of sections to make a line charge. In order to get the most accurate results, we would have to integrate it in order to get an infinite amount of sections on the line charge. So what if you had modeled each of your tapes as a single point charge, like in the previous lab? So in this lab, we got 3.16 e to the negative 7c, and in the previous slide was 2.55 e to the negative 8c. So this is almost 170% difference. This can show us that the point charge model was really not accurate at all, and that we kind of know that the line charge is more closer to the real value as the line charge is broken up into more points, and the tape is effectively in the shape of a line and not as a point. So over I found the net gravitational force, the net electric force, and then finally I found the charge of the tape as a line charge. I found that the difference between the line charge and a point charge calculator is significant, and lastly I found that in experiment there will always be error that skews the answer from the perfect correct mathematical error.